Okay, we're up to number 17 now, and we're told that we have to find the volume and the surface area of this shape that we've got here. Now read the hint carefully. It says the volume is the area of the face, which would be this triangular face of the prism here, multiplied by its depth. Its depth is 15 centimeters. Now whenever you work out the area of a triangle, you go a half times the base times the height. Pardon? So here I'm going to work out the half times the base of 6 times the height of 8. Now half of 6, you would all know that's 3. So really 3 times 8 is 24. And that's the area of the triangle at the front face. So we're going to go the area of the front face, which we've now worked out as 24, times the 15 centimeter depth. And you might like to pause there and figure that out for yourself. And the answer is 360 centimeters cubed, because it's measuring the volume. Now we're doing the surface area. Now when we do the surface area in question 18, we have to imagine that we're getting the triangular face at one end, at another end. So in a sense it's going to be 2 lots of the 24 centimeters squared we just figured out. Plus we're going to work out this leaning rectangle, which has measurements of 15 by 10. So that's a 15 by 10 means 150, but we'll do that in a second. So we've got 150 for that, and we had 48 for the triangles. Then we've got the rectangle that's underneath this shape, and that happens to be 15 by 6. So 15 times 6, and if you calculate that, that's 90, so plus 90. And the last one is the one that's on the left. Now that one on the left has a height of 8 and a length of 15. So it's plus 8 lots of 15. And if you calculate that, that's 120. Now pause it there and figure out all those numbers added together, please. And if you've done that and you're back, you should have got 408 centimeters squared. Okay, we're now up to question number 19, where we're using Pythagoras' theorem, and we have to figure out, if we can, the length of the hypotenuse. Okay, here's Pythagoras' theorem written down here for us. Remember, some teachers like to write it as c squared and a squared and b equals a squared plus b squared. That's obviously correct. And we can also use c equals the square root of the sum of the squares as well. So in this one, we're going to have c as our hypotenuse side, which is the side opposite the right angle. The a and the b can be the other two sides, and they can be interchangeable. B could be up here, and a could be down here, but we won't do that for this one. We're going to work out the square root of the a side squared plus the b side squared. Can you pause it and get your calculator to figure that out, please, now? And if you've done that, you should get 31.6 centimeters long. It says 1 decimal place, and we've done that, so that's perfect. Now we're doing question 20. We're trying to work out the a side, or the missing side is one of these shorter sides here. So to do that, we're using a bit of a rearranged version of Pythagoras' theorem. So we're going to say a is the square root of, now notice how it says c comes first, and c has to be the hypotenuse. So it's 20 squared minus the other side, which is b squared, 12 squared. And we're going to calculate that right now, and the answer is 16 centimeters. And we'll move on to the next one. Okay, we're up to question 21 now. It says we have to find the area of the shape listed here below. The formula for a full circle is a equals pi r squared, and the hint says what's the area for a semicircle, and that would be obviously pi r squared divided by 2, or a half pi r squared is just as good. So if we're doing the area, we've got to realise we've got a big semicircle, this whole big one here, minus a little semicircle just here. So we're going to have pi times the big radius squared is 3, so pi times 3 squared, minus pi times the smaller semicircle radius, which is 1, so pi r squared, and all that, because it's half of a circle, a semicircle is going to be divided by 2. So just pause and figure that one out now. Okay, you should have got 12.566 and a number of decimal places. Let's round it off to 12.6 centimeters squared for that one. Now it says we're going to find the circumference of that shape. I want you to imagine you're a little red dot, and you're going to walk around a semicircle, then a straight edge, then another smaller semicircle, and then along a straight edge and back to the start again. Now we're going to map out and figure out how long you've walked. So let's do that now. Figure it out. So the large semicircle part is 2 pi times 3 because the circumference of a full circle is 2 pi r. And then we're going to divide it by 2 because we're only doing a semicircle, as you can see. Then we're going to walk along this straight edge, which is 3 centimeters in length. Then we're going to do the small semicircle part, which would be 2 pi times 1 divided by 2, once again because it's a semicircle. Plus we're going to walk along the final straight edge, which is 3 centimeters. So just pause it there and calculate that long calculation there, please. Okay, I've got for that one 18.566 centimeters, and you could round that off to something like 18.6 would be perfectly fine. Number 23, we're working out the volume, and it says that we have to go pi times the radius squared times the height. So I want you to notice here that the radius is not given in this question, but the diameter is. So that means the radius is actually going to be 7 centimeters. So volume equals pi times the radius squared times the height here, in this case, is 20. Even though it's a lying down cylinder, we still say the height's 20. So just calculate that for me, please. And if you have, you've got 3,078.76. And this one, it's meters cubed because we're calculating volume and the units were meters. Okay, we're up to number 24 now. We have to convert all these numbers to a percentage. And the hint is that we're going to multiply them by 100. So 0.21 times 100 means we move the decimal point 2 places to the right because there's 2 zeros. That's the equivalent of multiplying by 100, which would be 21%. Half multiplied by 100, that should be an easy one. That's just 50%. 0.5 multiplied by 100. Okay, moving the point 2 places to the right, we're getting 5%. And this one's a bit of an unusual one. Moving the decimal point 2 places gives me 114%. Which is bigger than 100%, obviously. That's all right, so let's move on to question 25, where we have to convert to a simple fraction. The hint says, put over 100 and simplify if you can. So for the first one, we might write 5 over 100, but you might notice that simplifies because 5 goes in once in the top and 20 on the bottom, so the simplest fraction is 1 over 20. Now the second one, we've got 28%, so let's write that over 100. You might think, what's the biggest number that goes into 28 and 100? Well, 2 goes in, but there's a bigger one. 4 goes into the top 7 times and into the bottom 25 times. Now that can't be simplified further, so it's 7 over 25. 49, there's no number that goes into 49 and 100 other than 1, so we have to leave that as is. And then the other one, 225%, well, let's put that as a fraction over 100. You might think of a huge number that goes into both of them, and an obvious one might be 5, but there's a bigger one, which is 25, which goes in 9 times on the top and 4 times on the bottom. So you could write that as 9 over 4, but some people might prefer 2 1/4, which makes sense when you look at the actual number involved. Question 26, we're working at 11.4% of $220. In maths, when you see that word of, it normally means multiply. And because it's a percent, you can put this number out of 100, or if you have a calculator, especially the Casio ones, you can write shift brackets and it does it for you. Just stop now and work out what 11.4%, that means shift brackets, times the 220 equals. And if you've done that, you should have got $22.80. Question 27, Kira got 24 out of. Now when we see those words out of in maths, it normally means like a fraction or divide. And we're going to write it as a fraction and turn it into a percent because it says you got 24 out of 27. So that means turn it into a percentage. What percentage is this? So we multiply that by 100. And if you've done that, you should get 88. I think you get 0.8 repeated, but I'm going to round that off to 0.9%. Question 28. What percentage is 25 seconds out of 2 minutes? Now just notice they've got different units, and for this to work we really need the same units. So we've got 25 seconds. I want you to think how many seconds are in 2 minutes? Well, 1 minute is equivalent to 60, so 2 minutes must be double that, so 120 seconds. So we're really saying what percentage is 25 out of 120. We've written it as a fraction, Now we're going to multiply by 100. You can do that on your calculator if you want. And if you do that, you should get 20.8%. You might round that off to maybe 21% or something similar. Question 29, the last one for the day, says increase $28 by 30%. Now, some people say they like to do it this way. They like to find out 30% of $28. And if you were to do that, you'd work that out and you'd get an answer of, I think it's $8.40. And because it says increase, you'd add that to the original amount. A bit of a shortcut is that when you're increasing by 30%, it's the equivalent as working out 130% of the amount. The 30% is the extra bit, and the 100% that's in there is the original amount that you started with. So you might type this into your calculator and just try it for something different. 130% times 30. And if you do that, I bet you get straight to the final answer of $36.40, which is the money that we started with plus the extra bit that some people worked out. That's the end of today's. I hope that made sense, and if it didn't, please come and see me and I'll help you out with that.